Dear Professor Yana, dear Professor Capi, thank you very much for coming. Well, I would like thank you very much, my dear colleagues, to join ERAdiate lecture series 2 on the topic of collaboration with the Hosei University and in Japan and the intelligent robotics. So Professor Kazuo Yana is the director of the Institute of Integrated Science and Technology from the Faculty of Science and Engineering at Hosei University in Japan. And his presentation will be about the university and the faculty and the institute itself. Well, I was wondering what does it mean in reality, the Institute of Integrated Science and Technology, so I'm looking forward to find it. And Professor Genci Capi is from the same faculty, and he's a professor in the area of intelligent robotics. So how it came to this meeting, when we were preparing on behalf of the ERAdiate project, when we were preparing the International Conference on Intelligent Transport Systems in Finland the last year, so we were looking for the candidates for the technical program committee who will review the submissions. And from Professor Dado, we got the contact to Professor Genci Capi, who was a very committed member of the technical program committee and helped us a lot with the review of scientific papers. And I am very happy that this connection to Professor Capi and the Hosei University, which started with this long-distance connection, thanks to the conference we organized in Finland, has developed to this personal meeting we are able to have today. On behalf of the ERAdiate project, I would like to highlight that this visit and this lecture series is in line with the objectives of the ERAdiate project. And it's to enhance the collaboration, international collaboration of the University of Zilina. So let's hope that this is just the starting point, and this first visit will turn later on in a fruitful collaboration with Hosei universities, and let's believe that the University of Zilina will take this great opportunity and will start a real collaboration with Hosei universities and in particular with the faculty the both professors are coming from. So I will not talk too much. I think that we are a quite close group of people, and it would be nice maybe to start with a very short and quick roundtable to know who is on board today. Let's start with Professor Yana.
And my name is Kazuo Yana, and the former Vice President of Hosei University, and now the Director of English-based graduate program in Science and Engineering. And today I would like to introduce you briefly about our university, and followed by the research introduction of Professor Capi. And I hope you enjoyed it, and I hope this will be the start of the fruitful collaborations between our universities. Thank you very much.
My name is Genci and I'm also in Hosei University in the Department of Mechanical Engineering, conducting some research work in intelligent robotics, assistive robotics. So this is my second time in Zilina, really enjoying the environment and meeting some really very nice professors. So we hope that this visit will not be the last one. We hope to extend our collaboration in the future by extending some students, professors, and to be the first step in a long term for the better future of our universities. Okay, thank you very much.
Good afternoon. My name is Milan Dado. I am from the Faculty of Electrical Engineering, Department of Multimedia and Information and Communication Technologies, and I'm working with Chair project also. Thank you very much.
My name is Hosei. I'm a senior researcher who is currently working with ERAdiate and also being involved in another research and innovation project that granted last year, multi-project. So I'm very happy to see you all here, and I'm looking forward to have some kind of research collaboration with Hosei University.
Hello everybody, I'm Giuseppe Lugano from originally Italian but working here in Zilina since 2016. Still learning a bit about the Slovak environment, but already learning a lot on intelligent transport systems and also in a related area of sustainable mobility, involved in ERAdiate and Motive projects like Career. I'm project manager of Motive, and I'm particularly keen in your talks because previously I worked also on the area of social robotics, and I'm particularly interested in interaction between humans and social robots in the broader transdisciplinary context. Thank you.
Hello, I'm Yannick Cornet. I'm also a senior researcher here at University Science Park, working on the ERAdiate project and as well on the Value of Time project. Welcome here.
I'm a newcomer here, working on just started to work on the ERAdiate and the Motive project, coming from like former NCP, National Contact Point for Horizon 2020, spreading excellence and widening participation.
My name is Mario Alpesuri. I was invited by my colleague and I'm looking forward to hear more about science, technology and artificial intelligence. Previously worked for UN. Thank you.
Good afternoon everybody, my name is Martin Budak and I'm involved in the POD project, in ERAdiate and also in the Motive project. We'll be responsible for the data collection campaign nationally here in Slovakia and so on. So, thank you.
Hello, I'm Peter Tajabek and I'm from Faculty of Management Science and Informatics here from the University of Žilia. I'm working in the field of computer vision and especially in automation and information intelligent transformation systems, but I'm very interested also in broader artificial intelligence in the field of decision making.
Hello, it's nice to meet you. My name is Luboš Buzna. I'm from the ERAdiate team where I'm working as senior researcher, and I'm from the Faculty of Management Science and Informatics from the Department of Mathematical Methods and Operations Research. And my area of expertise is mainly optimization.
Good afternoon, everybody. I'm Jiří Zákutek and I'm from the Czech Republic. I'm an Erasmus student here, so it's my second week here, and I am on the Faculty of Mechatronics. I'm sorry, I'm still a little bit confused, so yeah, but I think this is the next. Thank you.
Okay, good afternoon everybody. My name is Peter Pokta and I am with the Department of Multimedia and Information Communication Technology. And in the context of this meeting, I am focusing on machine learning and human-to-machine communication. Okay, thank you so much.
Hello to everybody. My name is Aleš Janota. I'm the Vice Head of Department of Control and Information Systems from Faculty of Electrical Engineering. Thank you.
Good afternoon, my name is Tibor Petrov and I'm a PhD student at the Faculty of Electrical Engineering, the Department of Multimedia Information and Communication Technologies. And during my PhD studies, I've closely collaborated with the ERAdiate project. Thank you.
Good afternoon, my name is Eva Manichová. I work at Faculty of Management Science and Informatics, and also I participate in the Motive project.
My name is Kováčiková and I'm a PhD student on Faculty of Management Science and Informatics, and also I participate on Motive project.
Hello everybody, welcome again. My name is Lenka. I work for ERAdiate project, and a part of that I work with international students at the Faculty of Humanities.
Good afternoon, my name is Samia Zautkiova and I work like administrative support for ERAdiate project.
Hello, my name is Peter Ševčík and I work as a head of department of cybernetics. Please talk to me about.
Hello everybody, my name is Peter Brída. I'm with the Faculty of Electrical Engineering. Primarily I work in the field of mobile positioning. Unfortunately now I'm like administrative staff because I work as a vice dean at our faculty, therefore I have no time for doing research, but it will be good motivation for me restart my research career again.
My name is Yana. I am from civil engineering faculty people, and I am present in position of vice rector for science and research at the University of Zilina.
Hello once again. So my name is Tatiana Kováčiková and I am the ERA holder of the ERAdiate project.
And the last one, my name is Yana. I work at the Faculty of Electrical Engineering as a head of department of electromagnetic and biomedical engineering, and together with Professor Dada we are coordinating the ERAdiate project.
Thank you. So now I will pass the floor to Peter Brída, who will guide us through your presentations.
Thank you, Tatiana. I would like to thank again to ERAdiate team that invite valuable person from Japan. And I would like to invite the first speaker, who is Professor Kazuo Yana. Yes. And he is going to deliver a lecture about the opportunities for research collaboration and students exchange. They are part of the national Japanese project, if I could remember, during our first discussion. Right. So please, floor is yours.
Thank you, Chairman, for introduction. And today I would like to introduce you about our university briefly, and then followed by my introduction, and I will pass my microphone to Professor Capi to introduce his specific research topic, and hoping that we'll have some fruitful research collaboration from now on. Okay, so my talk is, first part is about our university, and then followed by that, I would like to introduce recently launched our graduate program in science and engineering, English-based. Hosei University is located in Tokyo, right central part of Tokyo, and we have 3 campuses, and I would like to introduce you about our university. And Hosei University was founded in 1880, quite a long time ago, and one of the oldest private universities in Japan, and also most popular and one of the finest university. And as far as number of applicants is concerned, we have ranked number 2 in Japan. So approximately more than 100,000 students applied to enroll in our university. And now we are trying to globalize the university, and the Japanese university generally are trying to globalize. And Ministry of Education, the MEXT is the Ministry of Education in Japan, launched recently a project called Top Global University Project. And there are more than 700 universities in Japan, and among them 37 universities are appointed as a member, and Hosei University is one of them. So we are trying to globalize our university aggressively. And now we have more than 200 partner universities all over the world, and I hope this university will be the next. Number of students altogether is 30,000, and we have 15 undergraduate faculties, 14 graduate schools, and 18 research centers. And also we have 3 affiliated junior high and high schools. We have 3 campuses, as I mentioned, and the Ichigaya campus is the central campus is located right central part of Tokyo metropolitan area. And we have 2 other campuses in suburbs of Tokyo. And most of engineering programs are run in Koganei campus, where we are from. And we have 3 faculties, Faculty of Computer and Information Sciences, and Science and Engineering, where most traditional discipline programs like mechanical engineering, electrical engineering are included. And also recently we have launched bioscience and applied chemistry, the faculties. Well, Hosei University itself is quite old and founded 1880, like I mentioned, but engineering programs are quite new, and I found that the history of our engineering program is close to your university. And our university is maybe 3 or 4 years older than your university in engineering education, founded in 1950. So it's 67, 68 years since founded. And like I mentioned, we have 3 faculties in the campus. Let me introduce you a few academic activities, characteristics of academic activities. We have some really distinguished professors, and one of them received Thomson Reuters highly cited researchers. His field is astronomy, the physics. And also we have IEEE Life Fellows and IEEE Fellows too. And another feature is we conduct high standard research collaborating with prestigious research institutions such as NTT, Hitachi or JAXA. And we encourage graduate students to present their research at international conferences. And one of the most unique professors is Professor Nagata. He found the cell reprogramming implant in 1970, quite a long time ago. Now you know iPS cell is booming in biology research field, but in animal. But he discovered the sort of iPS cell implant quite a long time ago, and his paper was the most cited at that time. And also he is known as Ig Nobel Prize winner, so not a Nobel Prize winner, but Ig Nobel Prize winner, and he invented the onion, which doesn't make people tears. But this invention is based on his serious scientific paper in Nature. So this is a unique professor. And also another a feature is everyone knows QR code nowadays, but the QR code was invented by one of our alumni, Mr. Hara. And so I first thought he got to be quite rich, but it didn't the case, because he opened the technology, not protected by so he opened the technology, and he's not rich at all. Okay, well, we have some international students, not quite many, maybe 5% or so. And some of the international student programs, we have double degree programs in computer science and information sciences with Chinese universities. And also I will tell you a little later, but we have launched English-based graduate program in science and engineering. And also we accept some exchange students or internship students. Actually, these photos are 3 students recently I accepted from Czech Republic, and they enjoyed research as well as Japanese culture. And also we have accepted the postdoctoral fellow from Czech Republic the while ago. And here we have many PhD students and also young faculty members. I would like to introduce you our grant fellowship programs for young faculties. So we invite the junior faculty or PhD student for 6 months to Hosei University, and we support travel expenses and also accommodation, and even we pay some salary to the junior faculties. So if you find some interesting topic, later the Professor Capi will introduce his research projects, and if you're interested in some projects, please apply for this scholarship to do the research, joint research with Professor Capi. And also we have visiting professorship programs, and we invite visiting professors, and depending on teaching duty, we have several the posts, and the visiting period will be from a half 1 year to or 1 month to 3 years. So we'd like to invite faculty members of this university to Hosei University. Okay, most of the classes and courses are taught in Japanese, but we have several English-based programs. Here I found some humanity graduate students. So we have MBA or programs, and some other programs not engineering field. And recently we have launched, and the program I'm in charge is the IIS, called IIST, Institute of Integrated Science and Technology. That is the English-based program, a graduate program in science and engineering. We have almost all field of study, starting from mechanical engineering to the biosciences. So from here, we'd like to introduce you some of the research project, and the robotics is one of the strong field, research field, and Professor Capi and a couple of other professors are working in this field. So after my talk, I'd like to Professor Capi to introduce his project a little in detail. And other than robotics, it's something to do with the name of our program, Integrated Science and Engineering. This is one example, the integrated science, integrating bioscience and computer science. So we have the unique program, educational program we have is clinical plant science, and we don't have medical school, but this is the sort of the alternative of medical school for plant. And this is quite unique programs, and we maybe in Japan only a few universities have this program. And so we have launched the research project to corroborate of plant science professors and information science and computer science professors, and to come up with, to develop the AI-based viral diagnosis system. That is an image classification of the cucumber leaf image. So we collected the big data of the photo image of the cucumber leaf and developed to identify the illness of the plant. So this is quite the big funded project and one of the examples of integrated science. I don't have time to introduce the research area of all faculties, but would like to introduce some of the professors. Here, Professor Ogawa is a leading scientist in the field of biomedical engineering, which your university is also strong. So he is president of Japan Medical Physics Society and doing research in image, CT image processing. And we have professors from NTT, and they are strong in network and security areas. And network security is one of the strong fields of our university, and we have distinguished mathematicians in algebra doing research in security, network security area. And his eldest number is 3. Have you ever heard the eldest number? No. Okay. So it is a measure how to measure how good mathematician is. And there is a mathematician named Eldish. He's I think Hungarian mathematician, and he published 1,500 papers. So he is a top mathematician. And if someone has a co-authored paper, then his eldest number is 1. So if the person has a co-author paper with eldest number 1 mathematician, then his eldest number is 2. So the Professor Katsura's eldest number, his eldest number is 3. So that means he's an excellent mathematician. So he's working in the field of computer security, network security. And also we have some visiting professors in computer security. Is quite a big name in the field. So on network security field, we have a number of good professors. And artificial intelligence and machine learning is also one of the strong field. Multimedia and augmented reality. So ubiquitous system or IoT field. So I think we can find a lot common research topics. So here I don't have time to introduce all their research topics, but again, we would like to match the research interest and would like to start some collaborations. Okay, this is a program for students. So we have some study abroad programs for Japanese students to study in foreign countries. Hopefully we'd like to send some students to this university to experience the international research experiences. And this is the information for the students who would like to study here at the Hosei University. So we have the master's and PhD programs. I know that you have strong master's and PhD programs, but we could share the educational resources. So if one of you wish to study the PhD programs here at the Hosei University, we have several support, financial support. This table, what this table shows is that the tuition will eventually balance, and you have to pay the initial cost, but we have a lot of scholarship and grants. So finally, at the end of the program, the in and out will be balanced. So, and this is also part-time work opportunity for graduate students.
Convert in euro.
In euro. Okay. Euro.
They consider in euro it will be very big.
So 160 yen. 160 yen per yen. Okay. So 2,000 is 16 euro. 16 euro for research assistant. 30 euro for teaching assistant. 35 euros for teaching assistant. So hourly salary is quite high, I think. And tutors also we have. So I'd like to summarize my talk. The Hosei University is one of the oldest and I can say finest university in Japan. And we are selected as a top global university project members and promoting globalization. And we have recently launched English-based graduate program in science and engineering. So we'd like to have some collaboration. Thank you.
Thank you, Professor Yana. It looks like very promising. I think that there are a lot of overlappings between your university and our university, especially if you take into account the Faculty of Management and Informatics and the Faculty of Electrical Engineering. So I open discussion. Do you have any questions related to this presentation? Please, Professor.
Thank you very much. Professor Yana, I would like to ask you, how is the procedure for application and for accepting of students from, for instance, from the University of Zilina to be a student?
The student, okay. Okay. The application period, the class starts from September, like here, I think, and the application period is just over at this time of the year. So the April and until May, middle of May, we have application. The end of April, we have application period. So at that time, we invite the application, and we do pre-screening. So first we we like to the candidate to submit the research proposals, and we match the supervisor and do some Skype meeting. So before making actual applications, we know the applicant's academic background as well as research topic, and match the supervisor.
Yes.
So that is the process. We require some English proficiency, but in your university students' case, that will be no problem. Yeah.
Thank you very much. Thank you.
I was just browsing a little bit about Hosei University and came across the Hosei Herald and from April 2018, so very recent. And I think it's as I understand, a kind of magazine in English written by the students at the Hosei University, but financed somehow within the university. It is very professional, and I encourage you to read. It is a little bit, I think, strengthening the community at Hosei University, and I'm very pleased because I'm also an international guest here to see that Hosei University is investing so much in internationalization from the grassroots. Also, this means making local people aware of the importance, for instance, of having a language policy, English, and making foreign guests welcome, and adapting procedures. And it is challenging. We are trying to do this strongly here at UNIZA, but we see that it is not only the work of a limited group of people, it is quite a big investment at the institutional level. So my question is, what was your first step in making a Hosei University more international?
More international.
To be able to attract more international talents, to be known, and...
There's two ways of interaction, and the student level and the faculty level. So not only accepting the international student, but we like to the bi-directional interaction and collaboration will be important, both in faculty level and the student level. So we have some programs, study abroad programs, to encourage our students to go abroad, and we have we launched some English-based programs and to acquire international students. Our numerical goal is we'd like to make the 10% of whole the student population be international. Like I mentioned, we have 30,000 students altogether, maybe so 3,000 students, and we'd like to make it international. It's a very hard goal, but that's one of the goals we have. But the number is not impractical, because in case of science and engineering educations, the students are divided into seminars and in senior, and each faculty have approximately 10 students per year. So maybe 10%, one student at any laboratory to accept international students every one international students per the faculty. So that's our goal to achieve. Of course, the faculties should be international and should do the world-class research, of course. And we are trying to make faculty more international too. Thank you for finding the journal. That's a part of our student activities.
Thank you for the presentation. Just a quick questions of things that popped up to my mind in your presentation. The first one is, well, also related to your question. What is the actual language policy at your university, also in terms of English? And then the second one, just I say right now, is about, because you mentioned that a lot of your courses were in Japanese, so how is that split?
That's it's a good question, and we are struggling for that. So now, at this time, at the present time, if the class has international students, the faculties are asked to change the language to English. But there are some problems also, because the Japanese students are not so proficient in English. So that is a problem we have to solve. But basically what we do is to switch language when international students is in the class.
And what about the management of the university for staff or professors or visiting people? Is that all in Japanese, or is there some level of English?
Now we have faculty development programs to internationalize, faculty development and also staff development programs to internationalize our faculty and staff. So actually we send some faculties to the US universities to train how to teach in English, and I also attended the class. So it was a really exciting experience because I have been teaching for a long time, and it's quite refreshing experience for me. But such kind of things, but still it's very slow, I should say. So, but younger generations, young faculty members don't have so much stress in giving a lecture in English. So the old faculties have some problems, but I think in 10 years the situation will be changed.
And then my second question was related to the possibilities of funding for visiting students and professors. I just want to know if, from your presentation, there's possibilities for PhD students and then for professors. I'm just wondering, what about the gap in between all postgraduates, like most of researchers here?
Okay. Our grant is from PhD students. PhD students is eligible to apply, and then the upper end is what we say junior faculty just got the PhD and started his or her teaching career. So not established professor or faculties. But in such case, we invite such kind of professors as a visiting professors and asking them to give a lecture in English.
Thank you. Thank you for your nice presentation. In one of your slides, you mentioned that you have already accepted some people from Slovakia and the Czech Republic. Could you tell more about that? What were your experience and who were they?
Yeah, okay.
They could be used for reference and to persuade our people, for example. So that's the reason I'm asking.
I see. Yeah, I see. There aren't so many cases. But in the year 2004, we have invited a postdoctoral fellow from Czech Republic and Czech Technical University, and spent, 2 years in the nanotechnology area. And I don't have now precise information, but he published a number of papers and also organized some international conferences. So this is the very successful model for us. And 3 young the students, the master students, visited my lab. It's happened to it's just a chance. I had a chance to accept 3 the Czech students, and they designed the hardware for satellite, a satellite measuring system, some data measuring system, and created the board, the electrical board, and did a wonderful job for just 3 months, and I think I can send you the papers they created. So they are really excellent students. So we don't have so many cases, but we accept some students from Europe. And most of the students, international students, are from Asia, China, and to Vietnam. And other countries. So, but we like to promote the educational research exchange with your country, with Slovak.
Thank you.
Yeah.
You have a chance to be first. So, please.
I had this question during the lunch, but I would like to share my knowledge with the rest of the colleagues. So you are the director of the Institute of Integrated Science and Technology, which is a very interesting name, and I would like to ask you what was behind such title. So did you have in mind multidisciplinary or interdisciplinary approach to research and science?
Yes. Yes, the word comes from what you mentioned, the research, interdisciplinary research will be the key for the future research area. So that comes to my mind at first. And also, like I mentioned in lunchtime, we have 3 faculties now, but the faculty has some historical background to be launched. So we have some duplications in areas. So we like to integrate the final or goal is to integrate the three faculties to be one big faculty of integrated science. And we're just trying to start the integrations by the integration of bioscience and the computer science, like I mentioned, in engineering. So it will be the future work.
Thank you. Research.
Accelerate the integration.
It's
the way how to integrate. Yeah.
I would also like to ask, basically, to make the environment internally and international, let's say, to accept the people from outside. We need basically to change mind of people working there, in administrative level, management level, teachers, researchers, everything. What is the main motivation factor for those people to basically to?
Yeah, this very good questions and difficult to answer. But like I mentioned, we have a global policy as a university whole. So we encourage the faculties and staffs to be globalized. So actually, some of the group of staffs, some of the enthusiastic staffs form the group to learn English and how to communicate with international students. And they created some booklet how to communicate with international students and so forth. So we like to encourage the staff and faculties to be globalized. But it's quite difficult. It's depend on the faculty and staff.
But basically, as you said, there is a global policy at
the
university.
Yes.
Is a basic stone for the globalization.
Yeah. Yes, that's right.
Thank you very much.
Thank you.
Now is the place for last question. No? Thank you again,
okay, thank
Professor.
Thank you.
Yeah, I would like to invite the second speaker, Professor Capi, from the same faculty. And now I think that we will hear more about the research in the field of intelligent robotic systems.
Okay, so now I'm going to talk what we are now doing in the field of intelligent robots at Hosei University. I am leading the Human Assistive Robotics Lab in the mechanical engineering and doing some research in assistive robotics, human-robot interaction, and also rehabilitation robotics, brain-machine interface. My today talk will be mainly focused in the brain-machine interface, but also some other research topics. Okay. So initially, I'm going to talk about the application of deep belief neural networks for the object recognition and grasping, especially in the now that the robot manipulators actually are getting to small sizes, the human and the robot can collaborate with each other in order to build some systems. For this reason, actually, if the human asks for something, then the robot must use its own sensors like cameras or laser rangefinder, for example, to recognize the objects and assist the human during the during operation. For this reason, in our method, we integrated a deep belief neural network and also the evolutionary algorithm in order to develop such a system. For example, in this case, the user actually can click on but it can use also natural language and can ask for some object. Then the robot, then the camera here, based on this image, the robot recognizes the object and give it to the user. Actually, in this case, what we are interested in is how we can, because the deep belief neural network, there are so many parameters that you can change these parameters. So we evolved these parameters using the genetic algorithm and also multi-objective genetic algorithm in order to minimize the learning time and also to increase the performance of the neural network, of the deep belief neural network. Here are some images actually that we use for training the neural network, the deep belief neural network, and also we used the 200, actually in this case we used 4 objects, but in the table there are many similar objects also. And here it is shown actually the structure of the deep belief neural network. I don't want to enter too much in details, okay, in today's talk, just I will give a very brief introduction because it will take too much time and maybe some of you are not interested in some research topics, so I don't want to, but so this is also very important, what is the input of the neural network. We decreased the number of the pixels to 28 by 28, and then are the hidden layers and the top level, and we used also the back propagation at the end in order to improve the performance of the deep belief neural network. So the training actually took place from one layer to the next one, and at the end actually we generated the recognition probability for each object. So as I already said, this is how we process the image from the RGB using some features during the training, and then the object is recognized. You can see, for example, in this case, for each object, there are 6 objects here, and there are 6 output units. For example, you can see here for object 1, the probability is nearly to 1, but the probability for the other objects is very, very low. And you can see that these diagonal values are nearly to 1. So for each object is a very high recognition rate. And here are shown what parameters actually we optimized using the genetic algorithm. So we optimized the number of the hidden layers, the number of the neurons in the hidden layer in the second and the third one, and also we evolved the learning rates and so here is the learning rate searching in this interval. And here is shown the multi-objective, the evolutionary algorithm. We use in this case we use number of individuals in each subpopulation, so there are 4 subpopulations, and each subpopulation has 25 individuals, so in total 100. In this case, actually, as I already said, the fitness function is how we can increase the performance and also how to reduce the time that the deep learning was trained. And you can see how the performance of the genetic algorithm, you can see that at the beginning the performance is very low, but during the evolution the performance becomes much better. And so how does it function during the robot operation? Initially the user clicks here in the object, then all the objects are detected by the robot, and based on and then begins the recognition process. For example, in this case, the user clicks on the object here. Then you can see the monitor. It is not very clear, but all the objects are detected. And then the specific object is recognized. If there are two objects that are similar, for example, this driver here and this one are very similar, are the same nearly, but the probability generated by the neural networks may be changed very little, and the robot picks up the object that has the highest probability and give it to the user. So now this guy is a postdoc in my labs using this postdoc scholarship from Hosei University for 6 months, and now maybe finding some job in Tokyo. We have also developed a robot for visually impaired people, because the reason is that not only Japan but even in other countries, people get blind when they are old. For this reason, it is very difficult for them to use the stick. And the dog is very, very expensive in Japan to train the dog for the blind people. For this reason, we developed such a robot which is equipped with 2 laser rangefinders, 1 camera here, there is a compass sensor and a GPS sensor here. And it is actuated by 2 Yamaha AC motors. Actually, it can navigate in outdoor environments. For example, in this case, it can recognize the step on the left and the right side and trying to move in the middle of the pedestrian. And so if there is only one step, the robot uses this sensor again to move in a determined distance from the step. And for the safety reason, actually, if there is a human in front of the robot, we can use the camera to recognize the face and the laser rangefinder to measure the distance to the human. What it is an advantage of this robot is that it can adjust the speed, the moving speed of the robot based on the moving speed of the human, because the laser can measure the foot location and measure the moving speed of the robot. And so in the open spaces, actually, the robot cannot use any step on the left or on the right side, so it can rely only on the GPS and the compass sensor. For this reason, we trained some neural networks, different architecture of the neural network, to see which one performs better. And this is the neural network 1, the structure. This is with some locally connected neural network 2, where the speed actually is fixed, but only the steer is the output. And the neural network 3 has 2 outputs. The speed so changes, but so the steering of the robot. And this is the training environment where there are moving objects. And this is the goal location. This is initial location of the robot. So we test it in different areas in order to generalize the neural network. And here is the fitness function. What is the fitness function in this case? Is that the robot has to get near to the goal, but also moving faster. So we try to minimize the distance between the goal location and the robot location, but also to minimize the number of steps that the robot moves from the initial to the goal location. And you can see some neural network 1. These are some simulated results. You can see that this guy, how hit the moving obstacle, cannot manage to get to the goal location. And neural network 2 gave the best performance, actually, very fast reaction when there are moving obstacles. And here it is shown the neural network 3. Actually, even in this case, they reach the object, but they catch the ear like this. So it is a little bit strange, like this one, for example. Yeah. So we implemented the algorithms in the real robot. Actually, this guy is not touching the robot, because maybe you would think that he is pushing the robot. For this reason, he didn't touch, but in the case of the blind people, he has to follow the robot, and when he stops, it recognizes. You can see the foot location here based on the laser rangefinder data. If there is someone in front of the robot, it recognizes, stop moving because it is very narrow, and then continues to move again. And the robot utilized the GPS sensor in order to know when to turn right or turn left, And also this part here is made by evolved neural controller. In this case, so we did some work in indoor environments, for example, in hospitals. We don't need to use some people, but the robot can guide the user in the, for example, in this case, going from the reception to the room. We use some landmarks in each room. So based on the color of these landmarks, the robot can recognize which room it has to enter, avoiding some obstacles and entering inside the room, moving autonomously. Because it is reaching now the room, it reduces the speed and entering inside the room. The door is very narrow, nearly the same, but it managed to enter inside. And now we are moving to a wheelchair robot, because many elderly people actually they cannot use very easily the joystick. For this reason, they just sit down and they can get to the. So we have some transportation systems. And this was some TV program actually for our lab. And now I am going to move to the brain-machine interface. We have done some work, but I didn't show the video here. In humans, we measure the brain signal in order to navigate the wheelchair robot, turning right, turning left in the decision points. But today I am focusing more on rats. We would like to use the rats' brain signals for the robot and to learn from rats how to navigate in the environment. We have a lot to learn from them. So this is the case actually when we fix the rat, and it has to learn initially to press the left and the right lever to eat the food. So the rat managed to press the lever and the robot. So in this case, the robot is in front of the rat, so it can press the right or the left, each of them. But in this case, you can see that if you're pressing the right one, the robot does not move. The rat has to learn only the left, to press the left lever in order to eat the food. So after some time pressing the right one, then it learns that this is not the right thing to do. So we start pressing the left one, and you can see that it managed to eat the food. And after this, after eating the food, we implanted in the rat's brain 8 electrodes. So we implanted 8 electrodes in the left, 4 in the left and 4 in the right hemisphere, and measured the brain activity during the rat's experiment. So you can see here how the brain activity changes. It is nearly not so active, but when it presses the lever, around 50 milliseconds, you can see that the brain activity change. And why this is important? It is important because we don't need anymore to see what lever does it press, but we can see the brain signals, and we can predict which lever the rat already pressed. So in this case, we trained the neural network using the rat's brain signal to predict the lever position, and we implemented it using this neural network in the robot implementation. And this was published some work also from another student just in PLOS journal, maybe 2 or 3 months before. Now we have moved to a much more complicated environment actually. This is, you can see that it is like Y-maze environment, and we have some food locations here. It is the size, it is around 2 meters by 2 meters. And these locations are covered. Okay, so you can see that the rat can smell it, but cannot eat. But this one is uncovered, only this one. So the rat has to learn only this route in order to eat food. And so the procedure is like this, that initially the rats learn the behavior, the trajectory, then we implemented the electrodes in the rat's brain, and pre-processing and then we use the evolutionary algorithm detection of the interval of interest. This interval of interest means the junction points. So in the junction point, the rat has to remember to turn right or to turn left. And after this one, we extracted the feature from the brain and use these features as in evolutionary algorithm and neural network to predict the rat, and then we implement it in the real robot. So this is the process of algorithm. This is the environment. It is 170 centimeters by 210 centimeters. We use some landmarks, and we covered with black curtain in order not to disturb the rat. And here is the dark environment. The rat cannot see anything. So these are some infrared LED in order to see the rat's location. And here is the training procedure. So we trained every day 10 minutes, 10 minutes every day to reach the goal location. And you can see how the rats, this is in the initial phase of learning. It is very slowly moving, sometimes moving in this direction. For example, in this case, very slowly. So we cannot wait to, but it is an intermediate phase of learning, moving a little bit slowly to the goal location. And this is at the last phase of learning, it moves very fast to the, and you can see here, because we use the camera on the top of the environment, that the blue pixels are everywhere scattered in the environment because exploring the environment, but you can see some, and at the end actually it's just moving very fast to the goal. Yeah, so, and here is this the dark environment, and after 8 days or 10 days of learning, they achieved a very, very high successful rate, around 95% or sometimes even 100% during the training. And you can see the time reaching the goal location reduced very fast. When we change some locations of the environment, the percentage rate actually decreases, but then in the dark environment. And then, because we made the training in the light environment here, the success rate is very high. When we change to the dark environment, the success rate decreases, but the rat managed to get again to the goal location. And this is the procedure that we implanted the electrode in the rat brain. It is not so easy. It is really very, very difficult. So we put 2 electrodes in the hippocampus and 1 in the stratum. And these are the electrodes implanted in the rat brain. So we did the surgery. And you can see the rat after the surgery here. Here is the preamplifier. Then we send the signal to the amplifier and reading the data in the PC. And we put some sensors, distance sensors in the environment in order to check the rat location when reaching the junction points. Here are the experiments, how we can measure the brain activity, and you can see the sensors data when it passes to this junction point, junction 1, junction 2, and junction 3. And here are the data from the hippocampus and from the stratum showing in this graph. And here it is, I don't know if you can see the rat or not. Yeah, you can see in the dark environment we put it so 1 LED on the rat's head in order to track the rat's location. And here it is how, so in this junction point, the rat decision, how it is made, which part of the brain is more important, to turn right or to turn left, and does the rat actually remember, for example, if I turn the first one right, the second one I have to turn left, and the third one I have to turn again left, or it is related to the location of the rat. So I'm in this location, and because I'm here, I have to turn right. This is a very important question. Which one did the rat choose? And which part of the brain is more, for example, stratum is more to the memory, and hippocampus is more related to the location. So this is the procedure that we followed from, we got the brain signals, we extracted the features, and based on these features, we evolved the neural network in order to predict the rat. We need only one output neuron because it is only turning right or turning left, so a binary unit is enough. And here you can see how the brain activity changes during the locations in the hippocampus and the rat 2, because we made 6 rats actually did these experiments. In order to, we put the time interval to process this data based on the sensor, the distance sensor here, distance sensor here, and distance sensor. So 1 second before and 1 second after the sensor's readings, as shown in this figure. And we selected 14 features, actually, as an input of the neural network. The features are here, 6 features, and the next slide maybe 14 features actually selected as an input of the neural network. Another issue is which feature is important. Not all these 14 features are important, for example, to train the neural network. So we left the GA actually to determine which feature is important by putting these 42 genes at the end of the genetic algorithm in order to determine which features are important for the rat. You can see that the neural network actually predicted very nice the accuracy rate for rat 1 and rat 2 using the training data 98.7%, and so with the test data 91% and 95% nearly. And here it is. So we left the GA actually to determine which one from these features is important for the neural network. And what is interesting is that we can see, for example, in this case, that nearly the same features are important for rat 1 and rat 2. And this is very interesting result actually, because it shows that nearly they use the same part of the brain for the decision making, but so they show some correlation between 2 rats actually for the features that are very important for the decision making. And we implemented this one in the real robot using, so in this case, when the robot reaches the junction point, it takes the rat's brain signals in order to decide to turn right or to turn left. So the robot is moving with the rat's brain a little bit. And now I am going to talk about the surveillance robot in the hospitals. During the night, for example, if there is no nurse or something, many bad situations can happen. So the robot can move autonomously in the hospital or lodging home or elderly people's home. And if something unusual happens, then the robot can contact the user and then can communicate and exchange. They can talk with each other, and so they can. And this is the robot side, and this is the user side. So all the sensors data are transmitted to the user, so they can see the sensors data, camera image, and like for example in this picture, you can see that there is the camera image, depth image, the temperature sensor and the pressure sensor shown in the user monitor. And here is the robot side. Why it is this monitor? Because in this monitor it is shown the user, so they can communicate with the elderly people, how are you and what is the problem, things like this. So in this case, initially the robot moves autonomously and enters in each room. If something unusual happens, how does it recognize if the person is falling on the floor? Is using the skin color detection. You can see the hand here and the face here. And so we think that in hospitals usually the person has the same color of their cloth. So by using this one they can recognize the... And you can see, for example, in this case, so the user can ask, do you hear me? Are you okay? Yes, I am okay. So, and if something happens, then the robot just informs the user, and then the control goes to the user. The user controls the robot using the haptic device, moving left, right, turning left, right, or moving forward. For example, in this video, and by pressing one lever in the haptic device, the control goes to the sorry, maybe I have to, yeah. So by pressing the one button here, then the control goes to this lever. So here are the pressure and the temperature sensors, so it can reach the skin of the elderly people. And here it is shown during the navigation. So the robot, using these landmarks, entering the room, searching for something. If everything is okay, it continues to the next room. And if something is unusual, then he informs the user. He is the user side monitor. For example, in this case, actually, initially, because it is someone in the floor, then the user controls the robot using the haptic device, getting near to the user, to this person, and then by pressing the lever, it controls the bow. And when touching the skin, you can see that in the monitor here, all the data of the temperature and other data changes, so it can recognize if the situation is good or not. So we are doing some work on the multi-robot system, formation of the multi-robot system. Here is the leader robot, and here is there are two follower robots, so they can see the leader robot and keep all the time a triangle, sometimes avoiding obstacles, but trying to keep the same formation during the navigation. In this case, we evolved the neural controller for such a using multi-objective evolutionary algorithm. So even if the leader rotates, then the robot also rotates and follow, keeping the same formation. And we have done also some work for this human-robot introduction. And because using this teaching pedant is very difficult to teach the robot, actually, in this case, it can use the cell phone or the haptic device of the Kinect sensor and teach the robot. It's a little bit noisy, but yeah. So in this case, actually, you can see that by opening and closing the hand, it controls also the gripper of the robot. So all these data are recorded in the control PC, and then the robot follows the same motion many, many times. So by using such devices, it is much easier to teach the robot rather than using the teaching pedant for the people. So these are some words that I wanted to present today. I just want to acknowledge my students that are in my lab, the postdoc and 2 PhD students, master students and undergraduate students. So this is the end of my talk. Thank you very much.
Thank you, Professor Capi, for a very interesting presentation.
Thank you.
At the end, Japan is linked with the robots everywhere in the world.
Yeah. And this localization also.
So, it's time for the questions from the auditor. Yes, please.
Actually, I have many questions. I can try to complete them. Feel too much of this topic. I would go to the very first part of the presentation where the robot was able to recognize the object, pick them
Yeah.
and use the deep learning network. One thing which was very interesting for me is to use a genetic algorithm to search through the hyperparameters. Was there any deeper analysis why to use a genetic algorithm? Because I heard a lot of opinion that for the neural network that these standard methods don't work very good to search the hyperparameter space. What's your opinion about it?
Yeah, actually, before we integrating the neural network and the GA, we just perform only the deep learning. We determined the number of hidden units and the learning rate. So for us, it was very easy to compare now optimized deep learning with the arbitrarily selected deep learning. And we found that it is much more, the performance was so the time, learning time was decreased, and the performance didn't change too much compared with the previous deep learning. And another advantage of this one is that we use a multi-objective genetic algorithm, because learning time and performance are conflicting. If you increase the learning time, you can get very good performance. But what we found is that because the Pareto optimal solution is like this one, we can find that for a very, very small decrease in the performance, we can reduce too much the learning time. We can decrease around 30% or 40% the learning time for a very, very small decreasing the success rate of the deep learning. So this was some advantage of using this optimization of the deep learning.
So it was compared to human expert who tried to define the architectures and this parameters?
Yes. Initially we used the arbitrarily selected, so the human thinks that I will put 1000 neuron here, I'll put 2000 neuron here. But is this good or not? By letting the GA to optimize this one, improve the performance. And initially we compressed the two objectives, time and performance, in one single objective using some weight connections, some weights. But later we moved to multi-objective GA. So each time and was one by one, not put it in a single function.
So we also tried to find the parameters which learn fast.
Yes.
Also. And the whole process didn't take too much time because a lot of experiments need to be made in different...
Yes, and another... Yeah. And sometimes these parameters have some connections with the time. Maybe you think that I decrease this one, but by making this one, maybe some other parameters will influence. So by letting GA, which is blind in searching, it is increasing much better the performance.
And the second question regarding is that when we are trying to do such a system, the number one always is how the system will react to unknown objects. Like when you showed this example where there were 6 objects, what is your experience with how to solve this problem? For example, if we put there a 7th object which the robot never seen before, how would it...
All the objects to be unseen, or only one object to be?
Only one.
Only one, to add a new object.
Or arbitrary number of new objects.
But the problem is that we already trained the deep learning with six outputs for each class of the object. If we put the 7th object, maybe it is detected, but which one... I don't know what to answer for this case, okay? Because it is like the output of it is for 6. And I don't think if it is completely unknown object, the recognition rate will be larger than this.
So basically the confidence will be low under some...
I think yes, sir. Yeah. Yeah. Yeah.
Okay, and the last question is, when I saw the rats and the maize, when they try to find the food, were there any observation made about if, for example, we have rat who already learned the task, and we change the food, if it's harder for this rat to relearn the new route against the fresh new one, if it's a much more difficult task for the rat.
So you mean after learning the route, we change the food location to another place? So it has to relearn the route, but we didn't test this, because in this case there are so many parameters to change. You can change for example, we tested changing we place some rectangular, some triangle on the left side, and we see how we change the rat position. Initially it faces but if we change 180 degrees, how it can manage to reach the goal. So there are so many things to change, okay? Lighting conditions.
I'm just curious because I also believe that in some situations also for humans it's much more difficult to learn
Yeah.
something than for someone who is fresh new to
Yeah.
learn individually.
Yeah.
So,
Yeah. Sometimes we change our apartment, we still go to the previous one.
Thank you. Any other? Please, Giuseppe. I have some questions that are not very technical, but more on the social aspects and connecting your research to the intelligent transport systems. So in my research, I told you earlier, I'm interested in social robots.
Mm-hmm.
And now working in intelligent transport systems, I also see the fully autonomous vehicle as a social robot, as a type of social robot, where you can also apply similar algorithms that you have, learning, and instead of detecting walls, okay, they can also detect people on the road and obstacles and so on. But one important aspect is rules that are codified. Another part is norms, socio-cultural practices. And I wanted to refer to your video with the chair for visually impaired people.
Yeah.
In that example, for instance, there was a kind of rule that the chair would stop if there is a person. But
it's not a rule. The rule is if the if the road is very narrow and there is not too much space to. In that case, the robot. But if it is wide enough that the robot can avoid, it is still possible that the robot continues its motion.
Because I was thinking that in a dense environment with a lot of people, this chair would be always frozen, and the person will never move.
Yeah, it's not that case.
For instance, or like in a natural interaction towards a kind of a visually impaired person with a chair like that, the other people would stop, and this chair would never find an obstacle.
Yes. Yes. In this
I don't
case,
know, of course, it was a kind of research experiment, but in a real setting, thinking about cars and thinking about robots interacting with people, how to embed this into the design of the algorithms? This kind of is it a kind of possible?
So even in this case, okay, because in outdoor environments there are so many conditions, and the conditions are different from Japan maybe to here. In Japan, maybe the number of population is very big and many people in the streets, but in some other countries are the problem, for example, the lighting conditions or the lights or the in pedestrians, for example, the robot cannot continue its motion because the pedestrians are in a certain height. So there are many issues, okay, that we have to consider. In this case we focused in some navigation algorithms, and absolutely this can be extended. For example, recognizing if the signal is red or is green. And so, as you already mentioned, maybe it is the permission to make such experiments is very, very something that keeps you a little bit from implementing it in a real environment. You have to be very careful not happening some accidents or something.
That's a good point. I think that, okay, as far as we see in a very controlled environment, we can see wonderful things. And then when people say, when this will happen in Tokyo, in Zilina, then projection, 10 years, 30 years, 50 years, never. I don't know, that's one...
the responsibility is must be very high for such,
Actually, when I was in Japan, one thing which amazed me was that even in very overcrowded spaces, no one bumped me. So maybe in Japan, you just make this distance very, very short and you can go on.
Okay.
It is more freezing.
My question is related to the middle part. I mean, the part dealing with the Red's learning. We could see that at the end of that part, you could see that you used the Swiss technology, the mobile EPAC robots. We use the same technology in our laboratories, but from time to time we face some obstacles or some limits. I mean, limits with computing power and memory and so on. So my question is, for the project you presented here, for the results, which we could see and hear here, did you use the standard commercially available EPUB, or did you have to change it, adapt it somehow?
No, it was but standard one. The reason is that our environment, the rat environment, was exactly the same with the EPAC size. We cannot use some other robot because it's wider or something like this. But EPAC fitted very well to this one. And it was the standard one. Yeah.
I have two questions. The one question regarding the wheelchair you presented in the indoor environment. What kind of positioning system do you use?
For the indoor environment?
Yeah.
For the indoor environment, actually, we trained the algorithm and the neural network using the laser rangefinder. We didn't use any
beacons,
any signal like RF or something in the environment.
No beacons.
No, it was completely autonomous. Every sensor is inside the robot. So we use the camera, we use the laser rangefinder and based on the neural network, it recognizes then the location based on this data. Yeah.
Thank you.
But you had two questions.
Might be the last.
Okay, so I have two questions, not the technical one, but one economic and the second one more social, concerning the trolley for blind people. The first one is that you started as that the motivation is that to train the dog is quite expensive.
Yeah.
So it means that this trolley would be cheaper than to train the dog?
To train the dog in Japan, I don't know here in Zilina, but in Japan it's around $220,000 US.
Oh, really?
Yeah. So it is really
because for
expensive.
me it was quite amazing, the motivation for this one. And the second one is more social, that sometimes those blind people are alone and the dog also is a partner for the person. So if you consider also this aspect in your research.
Maybe we can make only socially, if keeping the dog but not guiding by the dog can sit on the robot and can steal a robot.
Perhaps we can make a business to train a dog in Slovakia and then to import
Black market with animals.
But it was just a joke. Yeah. Thank you very much for a great presentation.
Okay, thank you.
I would like to ask you actually another question, because you're not originally Japanese, right? And my question would be following our project, basically, which is about the internationalization of the university. Why did you personally came to Japan, to this university, or what was the story behind coming from Albania, right?
Yeah. To Japan. But actually it is a very long story. So it is because I completed the PhD, maybe some of you are PhD students, so I completed the PhD and then I found a position in US in a Northwestern University. There is a Rehabilitation Institute of Chicago, but I don't know, some emails didn't function and it was something, so I decided to move to a research institute in Japan as a postdoc for 2 years, and then things went there and I joined now this Hosei University. So I'd like to use this opportunity to invite you. There is a application deadline just in 2 or 3 weeks for PhD students and for master students. So if you have some friends or some students, please they can contact me and we can arrange something. And so I would like to add, there is also another opportunity for joint seminar between Japan, Hosei University and your university. And we have to apply, you have maybe to apply to the Slovakian Academy of Science, and we have to apply to the Ministry of Education. And this kind of seminars or presentations are very important because we have some connections now and it's much more easier to get some approval. Or maybe we can organize something that not only from Zilina but maybe from Ostrava, Zilina and some other university we can join some seminar here or maybe in Tokyo first, and then there is also opportunity. Maybe I sent the link to Yana Sensei, but he forgot to put in the to the slide.
Oh.
Yeah.
Thank you. Chance for the last question.
Maybe I would ask about a more general question that mostly you presented the program to invite students, professors, teachers to Japan, to Hosei University. Do you have also the program to support bilateral visits, for example, to send the professors and students or PhD students, postdocs from your university here?
Yeah, actually there is sabbatical, so each professor can select for 1 year where to stay after 5 years in Hosei University. They can go abroad, but also there is opportunity because for a short period of time, for example 1 month or something, they can, during the time that there is no lecture in Japan, maybe they can still stay. Okay, there is no such a restriction for if they have some research fund or something, or yeah, they can pay also some from pocket money, no problem for staying some time in Zilina or in other. Yes, maybe Yana Sensei can add something or about this, or it's okay. No. It's okay.
Thank you.
Thank you again. I would like to thank everybody who are coming, and especially again thanks the ERAdiate team to prepare this interesting session, interesting lectures, and invite the guests. I would like to give you the mega last thanks to everybody. Thank you.
Thank you, dear professors, thank you, dear colleagues, for coming. So let's conclude this session with the words that maybe we will not start with something very big, maybe we will not start with some formalities, but let's start with some small projects that could be developed further on. So if we manage to have 1 or 2 students who will go, or if we manage to have this joint seminar, this would be already a great step ahead. So let's start with something small, concrete, and let's develop it later on. And thank you once again.
Thank you.